Let's find the probability using the probability of an independent intersection. So independent means that the events do not change as we perform an experiment. And we'll see that in the examples that we have here. And the intersection just means that we want multiple conditions to be met. So let's think about this first case. The probability of drawing a face card from a deck and then rolling a prime number on a die. So one, these are independent because the die roll is not going to be able to tell what happened on the card draw, right? It's an intersection because I'm looking for two different things to happen. I'm looking for an event where multiple conditions need to be met. I need to pull a face card from the deck, and I also need a prime number on the die. So the probability of pulling a face card and then a prime number on the die, out of the 52 cards in the deck, how many are face cards? There's 16 of them. And when you roll that die, how many options are there? There's 6. And how many of those are prime numbers? We'll count 1, 2, 3, 5. So there's 4. So remember, the probability of an intersection, if you need A and B to happen, is the probability of A times the probability of B. That's what we're using here. So when we go through this, 16 divided by 52 times 4 divided by 6 gives you 64 over 312. So there's 312 total universes that open up when you draw one card and then you roll the die, the 6-sided die. And out of those 312, there are 64 that satisfy the condition that the card was a face card and the die roll was a prime number. If you simplify this, you get about 0.205 or 20.5%. Let's work on the second problem. We would like to find the probability of drawing a red card from the deck, replacing it, then drawing a numbered card from the deck. So it's important that we replace it, because if we didn't replace it, then that changes the deck, and all of a sudden the probability of drawing a numbered card changes as well. So because we replaced the card and the deck, these are independent events. And I'm looking for multiple conditions to be met. I'm looking for the first card to be red and the second card to be a numbered card. So it is an intersection. So the probability of the first card being red and the second card being numbered, out of the 52, there are 26 cards that are red. On the second draw, because I replaced it, there's still 52 options. And how many of those are numbered cards? Each of my 4 suits has 9 numbered cards. So there are 36 different numbered cards inside that deck of 52 cards. When you simplify this, you get 936 out of 2,704. So when you draw from a deck of cards, when there's 52 cards in the deck both times, 2,704 universes open up, and 936 of those consist of you drawing a red card on the first draw and then drawing a numbered card. If you simplify this, you get about 0.346 or 34.6%.